let's actually just start from the far right, and I would like everybody to give a very brief introduction. So Chris Pinkham, he is CEO of Ningbula. It's a cloud platform company. Uh, Ningbula was recently named one of the coolest vendors in cloud platform by the research firm Gartner. Chris is a senior technology executive entrepreneur. He started his career in Cape Town about 20 years ago. Chris was very recently a VP of engineering at Amazon, responsible for global IT infrastructure. In particular, we have to note that Chris initiated and developed and launched Amazon's EC2 platform, which has become really a popular platform, has emerged as an undisputed leading public cloud infrastructure. So, Chris, if I may ask you to tell us a little bit about yourself and your background and what you do in the cloud and mobility space, that would be great.
Okay. Good morning, everyone. So my background is really internet technology, and this panel is particularly interesting to me because a number of different forces collide. One is the network. My first job was connecting the university I went to the internet in 1989. So I've seen an interesting migration of capability from those very early days when we were all an entire country sharing a 9,600 bit per second analog link to the internet, to the phone I have in my pocket here, where I was frankly a little astounded when you said smartphones are capable of 1.3, I think it was megabits per second. The device I have in my pocket, nothing particularly special. I regularly see over 30, 40 megabits per second, which I think is going to be very interesting from a services development point of view over the next several years. So I have interest in networks. I arrived at Amazon at the end of the go-go years when it was time to turn what was a very exciting business or concept into a real money-making business. Job number one was, let's stop throwing all the money away. Job number two was, how do we enable innovation, which is really what Amazon was all about. And I came to own responsibility for all of the IT infrastructure, the data centers, the networks, all of the software platforms that all of the development teams used. And it was a fascinating time trying to figure out how to, on the one hand, every year cut the infrastructure budgets. On the other hand, double the number of services, double the number of engineers we were supporting every year. So the sheer physics of that led to thinking about things in new ways, which culminated in, well, how about we stop manually operating all of this infrastructure? How about we stop providing all of these different customized services? How about we stop trying to predict what software engineers want and come up with tailored solutions for them? How about we just build this service very simple from the outside, very lightweight, very automated, not particularly opinionated in terms of its components on the inside, and we'll just open that up to the whole world just to prove that we don't have to spend months designing infrastructure for small software teams. So that was 2004 to 2006 era, and EC2 was launched. For better or worse, it seems to be the dominant true cloud platform out there. For a number of reasons, I decided my time was best spent building another company. This is Nimbula. We've been at work, Willem and I, for the past 3 years working on software infrastructure that takes a similar approach to the Amazon service does. And this may be a story you've heard many times over and over, cloud infrastructure as a service, cloud platforms. The perspective we have is that technology actually has yet to be built, that layering web services and user interfaces on existing enterprise infrastructure does not get you there. And that's just from hard-won experience a decade ago at one of the leading web companies. So I hope that wasn't too long-winded.
No, it's great. It's great. Very fascinating, actually. The next panelist is Sujit Day. Professor Sujit Day is with the Department of Electrical and Computer Engineering at the University of California, San Diego. This is where I met Sujit. First, Sujit also is an entrepreneur who co-founded Ortiva Wireless, a wireless video technology company, which was recently acquired by Allot Communications. He's now a chief scientist at Allot. Sujit is a very regular speaker at a number of IEEE conferences, and we are very glad to have Sujit here. So Sujit, similarly, can you introduce yourself a bit, your background, what you do?
Sure. So as Leon mentioned that one of the things that I have been working on for the last about 8-10 years is developing commercial grade solutions for rich media delivery over mobile networks. And by rich media delivery, we are targeting various different kinds of media, audio, web, video. And very quickly we realized that video is the one that is clogging the networks. And so we have come up with and delivered video optimization solutions and selling to carriers. So these are gateways installed in carrier networks. And one of the things that I've also started doing on the side, wearing my UCSD hat, is really started investigating what applications can be enabled by this huge growth in the mobile networks. Pretty much everywhere we are migrating to LTE. Leon talked about the smartphones and tablets. So what other rich applications can be enabled besides the ones that we already see today? And so the cloud became one of the resources in that research, in that search for new applications. And if you look at the convergence, one of the convergences, there are various convergences going on. One of the convergences in human expectation going on is that I have a rich device in my hand. It's higher resolution sometimes than even my TV. I have the promise of the LTE network. Why can't I just use the device as I use the regular internet, my desktop internet? And I showed some data in the morning that's where the expectation is going. But the device itself, however richer you make it in terms of number of processors and GPUs and so on, by itself it's not going to be sufficient because the applications and their processing needs are growing faster than what the devices are being capable of. So cloud computing definitely becomes handy here. And so one of the things that we have been looking at is how to enable rich mobile applications which are really tracking internet applications using cloud computing. But cloud computing by itself, that is the resources that are available in our cloud computing platforms by itself is not going to be sufficient, because now we have to also manage the problems of the mobile networks. Because mobile network, it has been established through a lot of debates and a lot of experimentation, a lot of statistics, is very different from the regular internet. And so what we are looking at is how to enable these rich applications by converging cloud computing resources with the mobile network resources. The cloud computing resources might sit in data centers around, on the internet backbone, or it can be brought completely to the base stations, the eNode Bs of the LTE network, with processing and caching at the very end at the very edge of the networks. So through a combination of these techniques, we are trying to enable rich applications over mobile networks.
Obviously, as I mentioned earlier, Ashok is a director of platforms and technology strategy at Samsung. I met Ashok actually at a number of conferences since late last year. He is responsible for recommending strategies to address technology and market trends, as well as strategic alliances. Now, one thing I want to let everybody know is that if you guys are interested in mobility and mobility trends, Ashok actually wrote a very nice piece. It's called "The Future of Mobility: 6 Trends to Look for in 2012." So it's available on wirelessweek.com. So if you do a search on Ashok's name, you will find the article. It's very fascinating and insightful. So Ashok, can you introduce yourself a little bit more and your background and what you do in the cloud and mobility space?
Yeah, my primary background is that I'm a software engineer by profession, and then moved into technology, and I've been in the technology space for over 23 years now. Used to work for Ericsson even before the Sony Ericsson split. Used to work for Nokia, Motorola, and right now Samsung. At Samsung, I'm responsible for technology and platforms strategy, and with a specific expertise in content and services. Taking a look at what are the kinds of technologies that are available and what are the kinds of platforms that are available, and how these can be meshed up to bring in cool, new, innovative consumer experiences in terms of content and services. So my team is responsible for basically getting a lot of content from various sources out there in the industry, and meshing them up with the user experience on the device to make sure that we deliver a compelling user experience for the North American market. I am also responsible for basically for the commercialization of these services, which means that take these, put it on the devices, ship it into the carriers, and making sure that the carriers are happy with whatever we are shipping, and making sure that the ultimate consumer experience is the best.
Okay, great. Thanks, Ashok. And the last but not the least is my former colleague at LG, Andy Smolik. So Andy is a director of solutions engineering and business development at Enterprise. And by the way, Enterprise stands for Enterprise Android, but they are now going to launch on iOS. So it's a very interesting name. I'm not going to talk too much about what Enterprise does because I want Andy to talk about it. But I have to note that Enterprise is one of the hottest, most promising startup companies in the enterprise mobility space, and it's based in New York City. And he previously worked for Avaya as well, so he's also a unified communications expert. So, Andy, please introduce yourself.
Thanks, Leon. We're in a really interesting space these days where we see the intersection of all these powerful devices, cloud services, and some really fundamental concepts like identity. What does digital identity mean at the device layer, at the service layer? And this startup, as you know, when I was at LG, I was doing dual persona strategy. There were all kinds of hypervisor-based solutions that we were working with partners on, all kinds of container-based solutions. There's dozens of companies that are in that space. And when I first crossed paths with Enterprise, what struck me is they had figured out a way to attach your personal identity and your work identity to separate containers, wrap a user experience around that. I like to think of it as kind of a body and soul thing, where the soul is the identity, the body is the container, and then you can start attaching services to these. And of course, my UC background with Avaya, one of the first things that I was excited about is this notion that, hey, now I can have my work telephone numbers, my work instant messaging and video attached in one container while I'm simultaneously on the same device having those personal services running, and I don't have to get confused between them. I spent the better part of 9 years at Avaya looking for ways to clean up the user experience around all these different multiple modes of communications that exist that we compose separately. We have different handles that we use for contacting, whether it's the E164 numbering system that we all know as dialing telephone numbers, or what we see now as instant messaging handles and email and Skype IDs and whatnot. And we've got this huge identity challenge out there of being able to associate those services with the right identities, being able to take the ownership of those identities, because I don't actually own my work identity. That's granted to me by my employer, right? So how do I allow them on a device that I've chosen to manage those services and capabilities and still respect some sense of what I do on the personal side of my device that doesn't need to be something the enterprise knows or cares about or even has any sort of legal liability for. So this is the problem space, and I've been fortunate. I started my career working on the Tomahawk program, and when I think about the graphics capabilities that we used to have on a silicon graphics machine, the size of a refrigerator, and what I get now on the SoC on a mobile device, it just blows me away.
Great. All right, so thanks for the introductions. We talk about mobile, we talk about cloud, and we talk about mobile cloud platform. But what is it? Is it just you take a mobile phone, you connect to the cloud, and that is cloud-based mobility? So how would you define mobile cloud platform? I think I spoke a little bit with Sujit yesterday. So Sujit, can you maybe start?
Sure. So as I mentioned, that one of the things that we first wanted to do was just take the cloud, and actually we started trying AWS, of course, and enable mobile services using the cloud. So for instance, if you want to do some video processing or rendering, use the cloud as the computing as opposed to do the computing on the device. But quickly we figured out through our field experimentations and lab experimentations that yes, this is great. That is, you're doing the rendering in the cloud, you're doing the video transcoding, whatever in the cloud. But first of all, it's becoming an interactive experience. So instead of doing something on your device, if you do it on the cloud, be it whatever application, what that means is you are giving your commands, entering things on your device, that is getting transmitted to the cloud is doing something and responding back, right? Immediately you are transferring simple application into an interactive application. And depending upon what the application is, for instance, if it is cloud gaming, then it is a very, very, very interactive application, right? Because a gamer would not wait for more than, 30 milliseconds, 50 milliseconds, depending upon the type of game, to get the what he's saying on the device. So now becomes a question that how do you manage response time on inherently fluctuating and dynamic wireless networks? So cloud mobility or cloud mobile platforms which do not understand and do not cater to the mobile network, to me is not a cloud mobile platform. To me, it's because you cannot just rely on a cloud platform and have mobile applications with the right kind of user experience if you do not consider in that same platform the mobility conditions. So to me, cloud mobile platform is a platform which not only supplies the infrastructure as a service, the platform as a service, and the software as a service, but incorporates in that mobility conditions into that, and does the right kind of scheduling, coordinates with the scheduler, and does the right things to ensure the user experience for that application.
Great. Anyone else? Maybe Chris, do you have any?
It might just get me going off on a tangent, but I just have no idea what cloud means. I usually end up retreating into kind of this philosophical point that cloud means I don't care. And so when you say something is in the cloud, and I think you had a list of wonderful companies up there, companies providing services from the cloud, in many of those they had very different delivery models. So if Netflix, for example, streamed movies, well, when you stream a movie from Netflix, even though a lot of the back-end computation happens in AWS, the movie is probably streamed from a level 3 or some other caching content delivery network. But if Netflix happened to have their own data center in California, would they still be in the cloud? So I think for me it boils down to a separation of issues. There are big challenges in dealing with mobile networks and mobile devices that are different to dealing with fixed line networks and traditional or slightly older devices. And I think those issues are separate to where is my computation happening, where is my data happening. I don't personally see a largely fragmented world, whether it's running on AWS. Google is apparently about to announce a competitor to AWS. I don't think that matters quite as much as what is the user experience, both from a data fragmentation, services fragmentation, social fragmentation point of view, as well as the latency, the experience they have in actually consuming an application. I would treat those as separate problems, personally.
Okay.
When we start about the cloud, right? Okay, I just see it as a old wine in a new bottle. Okay, think of the good old days of a client-server architecture. It's the same thing. It has been reframed as a cloud with newer terminologies with respect to latencies and connectivity with respect to mobile devices. That's the simplest.
I think it is easier to define cloud by what it is not than what it is. And for me, it's helpful to look at cloud and mobile as being flip sides of the same thing, right? When we use terminology like client server, we're thinking about networks being more localized. It could be a wide area network, of course. It could even be the internet. But there's a very tight relationship between the state management that happens on the client and on the server, and there's an immense amount of coordination. When I think of doing the equivalent as a cloud service on a mobile device, I'm really trying to simplify that interface as much as possible. I'd prefer to use a RESTful interface and have a minimum amount of state having to be shared amongst the two, and have as little local knowledge about the client on the server side and as little detailed knowledge about what's going on inside that service on the server side. And if I've accomplished that, then I can make a claim that this is a good cloud mobile service. If I haven't, then what I'm doing is trying to extend what I call a PC or Computing 2.0 concept into the mobile space. And of course we can do that, but just like trying to make every PC application a pretty shell around a VT100 application running on a mainframe on the back end, you're very limited until you finally let go of the previous generation model.
I'd just like to add one thing that so this is a little different from your specific question about cloud mobile, and I'm going back to what Ashok was saying, that when you in the older days or even now, if you try to build a service around data centers, you have to have a huge capex in the beginning, and you have to also customize a lot of the software. In a cloud-based application, hopefully you don't need to do that. Hopefully you can avail of the utility model, and hopefully you can avail of a lot of the software as a service stacks. And that should make developing the application also very different. And the feasibility of, obviously from a business sense, launching your applications also very different.
Please let me ask you a question. So what do you think what are some of the most important current and future mobile cloud applications? And in particular, can you name some of the mobile cloud applications and services that may disappear in the next 5 years? Perhaps we can start with Ashok.
Some of the most interesting mobile cloud applications is basically syncing your data across multiple sources. So there are solutions out there. For example, I am creating a PowerPoint presentation on my laptop. I just save it, and I head to a meeting. I can pull up my iPad, and it magically shows up there. Okay, or I use my phone, and it magically shows up there. Okay, there's tons of these cloud-based syncing applications available out there. And then one of the good use cases that we are starting to look at is basically giving a much better user experience and managing everything out of the cloud. So if I'm watching a movie when I'm driving on my car, I pause it, I come inside the house, I play it, it plays on the TV from where it just stopped, right? Okay, so those kinds of solutions are getting to be available as well. Tons of areas with respect to sharing data across devices. Think of a case where I'm watching a movie on my tablet. I can share it with my TV, share the screen across with my TV, or my refrigerator can tell me that it's out of milk, or if I'm sitting in my living room and my son is on the beach, he takes a picture, my TV stops and pauses and shows me that picture that was taken on the beach. Okay, it automatically, so the use case is pretty simple. My son goes to the beach, he takes a picture, it automatically saves a copy out to the cloud. The cloud knows that, okay, this is a family related experience. It automatically ships it back to a TV which is registered for that particular family. Those are some of the cool new experiences that we are looking at.
Can you think of any of those services that, or the services that you have not mentioned that will disappear, that people are using every day that might disappear?
If you had to rank your top 10 favorite mobile applications today and your bottom 10, I would bet that the top 10 all come from quite small, or until very recently were quite small companies, and your least favorite 10 all come from very large enterprises. So here's a bold prediction that large enterprises should probably stop building mobile applications. And if they don't, then consumers will just naturally migrate to the ones that work better. And in the same way that Mint.com, for example, aggregates all of your banking, your financial services applications, we're going to see that kind of thing being applied in other contexts, travel, retail, etc. One to your question, one thing that I'm surprised we haven't seen yet is the combination of online, offline, personalization, identity, travel, maps, all of that coming together in a single kind of application. You're driving down I-5, and the system, the bot knows that you've got a 5-year-old child in the back seat, and it's about time that that child's probably getting a little hungry, and your personal preferences intersect with your child's needs at a certain location, and magic, you're then navigated to a set of restaurants or something along the way. The flip side to what I just said about the small companies building applications is I think it makes it much harder to build those very tightly integrated experiences that brings together retail, identity. Small companies can only do so much.
What I'd like to be able to say is going to go away are these vertically oriented stovepipe solutions for everything from consuming media, right? I don't want to have an app that the rights holder is giving me so that I can watch a specific piece of media. I want to be able to watch that media where and when and how I want, right? What I think is going to happen is we're going to evolve so that the mass market kinds of media become more generalizably shareable, playable, viewable on lots of different devices, and we'll have some of that figured out, while this stovepiping problem will continue to run downstream, and now instead of having 5 different apps for this, I'm going to have 50, because everyone that thinks that their business model needs to be enshrined or that the data that they're sharing with me needs to be protected decides that they're going to build their own custom app for that instead of making use of common infrastructure to accomplish the same thing, and I'm going to end up with 50 individual apps for each of those content providers. That, unfortunately, I think is going to be the reality, at least for the next 5-10 years.
Yeah, as I was hearing your question, I'm pondering like this, and I don't have a clear answer, but I'm going to think fundamentally the question that what is a cloud going to enable on my mobile which cannot be enabled by my native application today? So one thing that you mentioned was cross-platform compatibility, cross-platform use. And that's, I think, going to be extremely important and obviously very productive. The second thing is that what kind of computing, what kind of storage, what are the things that are not available on my device that can be supplemented with the cloud? And what are those kind of applications? So, and then what other applications can migrate to the cloud? And I think that there's a lot of migration going on the cloud from native to cloud. But then the mobile also has its own advantages, right? The cloud doesn't know your location. The mobile knows your location. The cloud doesn't have the sensors on your phones. The mobile has sensors. So what I'm thinking is that what we'll see is growth of hybrid applications, And so this is where I think a lot of innovations can happen. But the other thing I'm also thinking from your question is that can it be disruptive? What's going on, the migration of native applications to the cloud, how disruptive can it be? Can it, for instance, bring down application stores or reduce the importance of application stores? Can the confluence of HTML5 and cloud make businesses deliver services not by distributing apps? And I'm sure that that app growth that you mentioned, the revenue will continue. But does it have to be where content providers need to give 30% to Apple or 20% to someone else? Can it be done in a different way? And I think that in the next several years we'll find answers to those questions.
Absolutely.
One comment on this, the application side of things is that okay, there is always an app for that, right? Okay, there are 500,000 applications on the Android market, and how much are really making money? Probably about less than 10%, right? So making sure that okay, these application experiences are better integrated experiences rather than standalone siloed experiences. A good example that I always say is you walk into a house, okay, you go through the door and then you go to the kitchen. For you to go from the kitchen to your bedroom, you don't go to the door again and then go to the bedroom. Okay. Right now, all these application-based experiences are vertical siloed experiences. So you need to go back to your home key to go back to the home and then start off on another application. A good example is if you're playing Netflix, right? Okay, from Netflix to Hulu, you cannot jump. Or from Netflix to Facebook, you usually don't jump. You got to close down on Netflix and then go on to the Facebook, right? So those kinds of vertical experiences would technically go away, and basically what would happen is a much more deeper integrated experiences, cross-application, cross-platform experiences would be the future.
Great. So let's shift the gear a little bit to the enterprise world. And as Chris, you earlier touched upon, is that you suggested large enterprises should stop building mobile applications. But let me just, ask you this question: is in your view, what are some of the biggest challenges when enterprises extend their applications from the legacy kind of PC only to cloud and then ultimately to the mobile devices?
So let me treat those separately as per my earlier prescription, if I may. So mobile devices, I think the challenge there is that it really does require a refactoring of the entire customer experience just to kind of get functionality roughly on par with the applications that you had offered through other mediums. And that seems to me to be where a lot of the energy from an enterprise application development point of view happens. What I don't see much in enterprise offered applications is a radically new way of thinking about how it is that they're presenting services that are important to their customers. The cloud story is a slightly different story. We chose the model we chose at Amazon for a couple of reasons. One of which was we wanted to provide an abstraction that wasn't too different from the abstractions that software developers were familiar with. It was kind of different enough that it messes a bit with people's heads around the fringes, but at the core of it, if you've got Windows machines running in Windows operating systems, these things can operate in the Amazon cloud, and you can even, if you want to, treat it like a machine, manage it like a machine, put in machine management agents and so on. So I don't think for any kinds of applications that have grown up in this commodity server world that there are fundamentally unsolvable issues. There are issues around getting comfortable with the operating model of AWS, for example, or some other service provider. To the extent there's discomfort with security models, these things are solvable with different kinds of business models, and Amazon's made some progress in demonstrating these. So where it gets kind of interesting is in the stuff that really hasn't grown up in that Windows Linux world, and there, frankly, I'm not sure. It's not a world I grew up in, so maybe I'm the wrong guy to to ask around those kinds of things. Largely, my final point is I'm continually astounded, and I hope none of my enterprise customers are watching and listening here today, on how badly organized in general enterprises are around innovation. From an incentive point of view, from a hiring point of view, from a project prioritization point of view, I think there's a really good reason why companies like Apple and Amazon are giving everybody such a thrashing at the moment, is because they're fundamentally organized around innovation, and I think that's probably the biggest single challenge to any non-technical enterprise in a fundamental sort of transformation. And when you have multiple of them going on at one time, I think it must be very confusing.
How many real-world service providers are willing to put what they do out in a form that could become a very simple RESTful API, right? Put their core value proposition. If I'm a rental company, how can I abstract what I do down to a very simple RESTful API and then make that integrated with all the other potential experience entry points to be able to add value there, right? Instead of focusing in on what is their core competency and the place where they're making their money, what they're doing is trying to take old systems and take something that works reasonably well with a mouse and a static computer screen and translate it to something that's now using fingers, and it's a horrendous experience, and you lose more than you gain in most cases. What needs to happen is a willingness of the enterprise itself that's offering that service to say, you know what, I may not offer everything to everyone in the world like my annual report says. I'm good at these things. These are what I want to expose, and these are the people that I trust to make use of that interface and build on that. And really, it's only the small companies that are doing that today. And if they do it well, they're rewarded for it, right? The large companies don't even seem to understand what business they're in 9 times out of 10 if you were to judge by their mobile applications and the cloud services that they expose.
Great. So earlier, as you saw on one of the slides, a report projection by Cisco's VNI mobile organization is that video traffic has exceeded 50% of all of the mobile traffic. What are some of the technologies that are emerging that will optimize the delivery of videos for mobility or other rich media to save bandwidth, improve efficiency, and ultimately enhance user experience? So perhaps, Sujit, you could take a stab at it.
Sure. No, so this is real. This is, when I look at market research, I have a healthy respect for market research, but I, do not take into account too much the predictions. But this one seems to be real, and actually, in my view, the Cisco Visual Index might be actually lagging behind because it is not looking at some of the other emerging things, I think, which will come and flood the networks. No, so this is a real problem. We, as I mentioned, have been working on video optimization technologies for several years. We have various technologies deployed. Obviously there is no magic. That various networks around the world we see where honestly the networks should not be capable or are not capable of giving you a real good video experience, and then there's some other networks which are being upgraded fast and has the capacity. The threat is really coming from the devices, and thanks to Samsung and LG and obviously led by Apple and others. That the devices are becoming not only capable of displaying much higher resolution and sometimes competing with the TV, but also being able to record or have the cameras which are very, very powerful these days. So what we are starting to see is not only the downlink traffic the video traffic, but also the uplink video traffic. And that makes it particularly painful, the uplink video traffic, because as we know that most of the networks are today asymmetric, and LTE makes it better, but still there are problems. So in terms of answering your question, what specific technologies, essentially the two main technologies I'll mention is that understand. See, most of the video today being watched on mobile networks is on TCP, because these are all internet video. It has become very skewed towards over-the-top video. So in over-the-top video, it's TCP. So the technologies need to understand what the TCP behavior is, and if most of you know what the TCP behavior is, that whenever it sees congestion, TCP starts to shrink. So these technologies need to essentially address, and modify the TCP behavior to make sure that video goes through. On the other hand, it also needs to address the concern that carriers have, and that is the overflooding of their network. So what I would say is that two facets of the technology. One is ensuring user experience, but the other is applying various dynamic rules and policies to ensure that the traffic remains under control, so that the other kinds of traffic, the voice over IP traffic, the web traffic, all those traffic also can flow. And ultimately, it's not about just data savings. It's about saving at the right cell. So there are only a few cells which are getting congested at any given time, and the focus should be on how to increase the capacity of those cells.
Great. Anyone else? Or
I'd argue that neither TCP nor UDP do a good job at all with real-time communications traffic. Streaming, we can kind of fake it, but even then, the network doesn't have a good way of knowing midstream, okay, this is something that I just need to discard because it's less important than other traffic that's flowing through. The worst scenario is where you've got a situation where because of congestion, you've got somebody on a real-time voice or video call. You can actually see inside the network that packet is going to arrive too late to even be played out on the far end, and you don't have a way of discarding that cleanly. That to me argues that we need to be looking at other, not just TCP and UDP as solving all of our potential problems, but look at even at the lower levels of network design, what's necessary to allow the network to discard this traffic that doesn't truly need to or won't even be useful if it's forwarded.
It's absolutely, if I may add one thing, absolutely true. But if you look at the ecosystem that has emerged and how control used to be, both from a user perspective as well as from the content perspective with the carriers, and how control has shifted pretty much 90% to the content providers. So the source of the content and the pipes have become more disjoint today than ever before. And so any technologies which sits in the network and has to rely on changing how the content has either been containerized or what encoder it is using or what protocol it is using will have huge resistance, because a lot of the content is becoming DRM'd also. So that's another thing that we are watching, that a lot of the mobile content, 90% used to be just non-DRM content, but it's becoming more and more DRM. So anything that you think of in the middle of the network has to be something which is compliant with what is being streamed from either end. And this is where I think what I'm hoping for is more collaboration between the content providers and the carriers will have to be done in a mutually beneficial way to address this problem.